Hi everyone. In this video, I will be explaining network topology. This topic is included in power system analysis for electrical and electronic students, pre-final year and final year students it is included. So, in this video I will be explaining what is graph, what is subgraph, what is how you write the tree, co-tree of a oriented graph, and incidence matrices. First, let us understand what is graph. What is graph? Graph in a network, it shows the geometrical interconnection of elements. As you see in this figure, it shows the oriented graph. What do you mean by oriented graph? So, the graph which deficits the element directions which terms to be the oriented graph. So, a graph is connected if and only if there is a path between every pair of nodes. If each element of the connected graph is assigned a direction, then it is oriented. If you see this figure, we have a oriented graph. In this, the elements are marked as 1, 2, 3, 4, 5, 6, 7. So, the total elements are 7. And we have nodes. So, the nodes are marked as encircling the numbers 1, 2, 3, 4 and 0. Here we are considering the 0 as the reference node. So, totally we have 5 nodes. So, the number of nodes are 5. So, the node and the element are incident. What do you mean by incident? Incident means node should be the terminal of a element. Node should be the terminal of the element, then it is incident. So, here the line segments, that is elements. So, these line segments are called elements and their terminals are called nodes. Example, if you take the first one, the element 1, it is incident to the first node and the reference. That means, this element is incident to 1 node and 0th reference node. Similarly, the 6th element is incident to first and second nodes. So, here you understood what is graph and how to write the oriented graph. So, here these two are very important. So, in the university exams they keep on asking the definitions with illustrative example, the graph and the oriented graph. I repeat, graph is the geometrical interconnection of elements of the network, and oriented graph is nothing but if you assign a direction to the elements in a graph, it becomes oriented graph. So, the graph is connected if and only if there is a path between every pair of nodes. So, after this understanding the oriented graph, let us understand how to write the tree. For writing the tree and co-tree of the connected graph or the oriented graph, this is oriented graph. This is same as the slide, the previous slide I showed, the same figure. Here it is taken oriented graph to deficit the tree and the co-tree. So, the connected subgraph containing all the nodes of the graph but no closed path is called tree. So, this also they will ask, the third definition they will ask in the university exam, that is tree. What do you mean by tree? So, it is a subgraph containing all the nodes of the graph, but no closed path. Example, let us consider these the elements 1, 2, the elements 1, 2, 3, 4. We will consider only these elements. See here, if you consider the elements 1, 2, 3, 4. These 4 elements are not forming any closed loop, but these 4 elements will cover all the nodes of the graph. So, the definition says for a tree, it is the subgraph containing all the nodes of the graph 0, 1, 2, 3, 4. It contains all the nodes of the graph, but it won't form the closed path. It is called tree. So, the elements of the tree, here the elements are 1, 2, 3, 4. These elements are called branches. The elements are called branches. These branches, how many branches here? 1, 2, 3, 4. So, this is equal to nodes minus 1. How many nodes? Totally we have 5. 5 minus 1. So, number of branches are is equal to nodes minus 1. The formula is branches is equal to nodes minus 1. So, this is the explanation for tree. With an illustrative example, one should explain this concept. Next, we will consider the topic, that is co-tree. The elements which are not included in the tree. See here, the elements which are included in the tree are 1, 2, 3, 4. The elements which are not included in the tree are 5, 6, 7. If you see the previous slide, here you can see that the elements which you are not considered in the tree are 5, 6, 7. 5, 6, 7. Let us consider these 5, 6, 7 with the broken line or the dash line. So, 5, 6, 7. So, this is 5, 6, 7. We will consider the same 5, 6, 7, and direction also let us consider it as same 5, 6, 7. So, these 3 elements which are not included in the tree, that is 5, 6, 7, they are called links. They are called as links. So, those elements of a connected graph that are not included in the tree are called links. So, not necessarily connected. So, these 5, 6, 7 not necessarily they are connected. So, this forms the subgraph. So, this a complement of the tree is nothing but co-tree. So, the elements of the co-tree are called links. So, the links are equal to elements minus branches. So, total elements are 7, the branches are 4. So, this becomes 3. So, the formula for links L is equal to E minus B. So, the formula for number of branches equal to n minus 1. This is how we can define with an illustrative example the graph first thing, and then they will ask oriented graph, and then they will ask the tree, and they will ask the fourth topic, they will ask co-tree. So, with this you understood the things related to the graph, subgraph, tree and the co-tree. Next, let us understand how to write the incidence matrices. So, totally we have 6 incidence matrices. So, the next topic is incidence matrix. So, this incidence matrix, we have different types of incidence matrix, that is A cap, A. So, A cap is called, this is the notation for element, node, incidence matrix, and this is bus incidence matrix. So, in this video I will be explaining these two concepts, that is how to form the incidence matrix from the oriented graph. Let us consider the same oriented graph which it is shown here. Same, I will be taking the same oriented graph. I will be copying the same oriented graph. This is the oriented graph I considered. So, for this let us write the incidence matrix, that is A cap. So, the A cap is nothing but element node incidence matrix. So, that means, see, let us consider the A matrix. The order of the A matrix, as the name itself is telling, element cross nodes. So, how many nodes are here? 0, 1, 2, 3, 4. So, let us consider all the nodes 0, 1, 2, 3 and the 4. So, let us consider the elements also 3, 4, 5, 6, 7. Let us prepare the matrix table 2, 3, 4, 5, 6, 7. It is very easy to write the elements. So, the elements of the A matrix, either they are 1, -1 or 0. Only 3 types of elements are there in the A matrix. So, when to write the element value 1, when to write -1, when to write 0. So, this is very simple. So, these element and node what we are considering, see, both are incident and oriented away, then we will consider it as 1. Example, the first element, let us see the first element and the first node. First element and the first node. See, the first element is incident to first node, but oriented in the same direction. Similarly, if you consider the fifth element, so the fifth element is incident to 2 nodes, that is 1 and 2. So, in this let us write the matrix elements. Let us write the matrix elements here. So, the 0th node, if you observe, 0th node is incident to 3 elements, 1, 2, 3. So, 0th node is incident to 3 elements. It is touching with 3 elements 1, 2, 3. Let us mark 1, second element, third element as 1, 1, 1, and the 0th reference node is not touching the elements 5, 6, 7. So, it is not touching. If the element is not incident on the node, then we consider it as 0. So, I repeat. So, first element, second element and third element are touching the 0th node. Therefore, I written 1, 1, 1, and the remaining elements 4, 5, 6, 7. These elements are not touching the 4th node. So, therefore, it is considered 0. So, when to write 1 plus 1 minus 1? See here, 0th reference node, the current direction in the elements 1, 2, 3 are away. If they are away, then you should write it as plus 1. So, next let us consider the same scenario in first node. First node is incident to 2 elements. This is 0. This is 5. This is the arrow mark. See here, the first node is incident to 2 elements 1 5. See here 1 5. The remaining elements 2 3 4 6 7. These elements are not incident on first node. So see the directions. The first element is carrying the current into the node 1. It is incident, 1 it is written, oriented towards means minus, away is plus. See here, fifth element carries the current away from the first node, therefore it is plus. Similarly, the second node. Second node is incident to how many elements? 4 elements. There are 2, 6, 7 and 5. So let us mark that second node is incident to second, 5, 6, 7. These elements 1, 3 and 4 are not incident to second node. So here plus 1 or minus 1 we have to decide. So here let us consider the second, it is going in, therefore it is minus. Next fifth one is going in, minus. Sixth one and seventh one are going out, therefore it is plus 1. Similarly, you can write the third node. Third node is incident to only 2 elements 4 and 6. 4 and 6. Remaining elements are not incident to the third node. And let us mark these directions as minus. Why? Because the at 3, so the currents in the elements 4 and 6 are coming in, therefore towards 3, therefore it is minus. So let us consider the last node, that is 4. So it is incident to 3 elements 3, 4, 7. 3, 4, 7 and remaining elements 1, 2, 5, 6 not incident to fourth node, and we have to write plus 1 or minus 1. See 3 is into, therefore minus, 4 is going away, plus 7 is minus. So this is how we can write the A cap matrix. A cap matrix is nothing but element node incidence matrix. The order of the matrix is equal to elements cross nodes. Next, let us write the bus incidence matrix. This bus incidence matrix is nothing but elements cross n minus 1. So if you omit reference, that is, this is the reference I considered, 0 is the reference. If you omit the column corresponding to the reference node, then the matrix becomes A matrix. If you exclude this, then the matrix becomes A matrix. So in this video, I explained how to write the graph, subgraph, oriented graph, tree, co-tree, and 2 sets of incidence matrix. One is element node incidence matrix and bus incidence matrix. Let us consider one more example. With that example, let us understand how to write the. This is an example I considered. This is a oriented graph. Oriented graph. Let us mark the directions for this. So the directions I am marking as per this problem given. 1, 5. So these directions and the structure of the elements will be given. So 1, 2, 3, 4, 5, 6, 7. See here, I considered a oriented graph. For this, let us understand how to write the A matrix. So the A cap matrix is nothing but, as you all know, it is the A cap matrix order is nothing but element cross nodes. So we have 7 elements and we have 6 nodes. Okay, let us write the nodes A, B, C, D, E, and the elements are 3, 4, 5, 6, 7. This is one of the additional example I considered to explain the construction of incidence matrix A and A cap. So, here the reference node is 0, reference node A, B, C, D, E I consider. So, A, B, C, D, E and one more, that is the reference. So, that is the reference I considered here, reference can consider. Reference also we can consider. Now, let us consider the A node. A node. So, A node is incident to how many elements? 1, 3, 5. 1, 3, 5. The remaining elements, that is second, fourth, sixth, seventh, not incident to first eighth node. So, directions A1, the first one, first element is towards. Next is 3 is away plus, 5 is away plus. Similarly, B. So, Bth node is incident to 3 elements 2, 3, 4. 2, 3, 4. Remaining element 5, 6, 7 and 1 not incident to Bth node. And you see the directions 2, 3 are towards B, therefore it is minus. Fourth is away plus. C, it is incident to 2 elements 4 and 6. 4 and 6. Remaining element not incident to the particular node C. And directions, if you see, fourth one it is into the node C and sixth one is away, therefore it is plus. Next to D, 5 and 7. 5, 7. The first element, second element, third element, fourth element, sixth element not incident to the node D. So, we have to consider these 5 and 7. 5 is towards 6 is 7 is away. Next is E. 6 and 7 are incident to E. 6 and 7. Remaining elements 1, 2, 3, 4, 5 not incident. 6 and 7 both are towards the node. Therefore, it is minus. Next, let us consider the reference. It is incident to only 2 elements 1, 2. 1, 2. Remaining elements 3, 4, 5, 6, 7 are zeros. 0. So, here 2 is away, both 1 and 2 are away from the node 0. So, this is how let us write the A cap matrix. A cap is nothing but element node incidence matrix. Right? Element node incidence matrix. So, in the last slide I explained how to write A matrix. A is nothing but element cross n minus 1. So, this is bus incidence matrix. Bus incidence matrix. This bus incidence matrix is nothing but it has same number of A cap rows, that is 7, and reference node. See here reference node is there now. See these reference node elements, if you omit, then if you omit, this becomes A matrix. It has only these elements cross buses. Buses are nothing but nodes minus 1. I hope you understood the formation of incidence matrix, oriented graph, tree, co-tree in the network matrices concept. Thank you all.